They slid a person who was hallucinating into a brain scanner and watched their sense of self come apart in real time. For 2,000 years, this dissolving of the I belonged to mystics, a oneness with everything, the boundary between you and the world melting away, something you took on faith. Now it has a location in the brain, and, it turns out, an off switch. Somewhere in your brain, a network is running right now. Its job is to maintain one feeling, the feeling that there is a you. A single dose of one molecule can turn its volume down. And when it fades, people describe the most meaningful experience of their lives. This is inner cosmos, where science meets wonder. And tonight, we ask what the scans actually show when the self comes apart. Here is the real mystery, and it is actually two mysteries stacked on top of each other. The first, what happens during the trip itself? The second, stranger one, why can a single dose change a brain for months afterward? The scientists who study each question don't fully agree with one another. That disagreement is where the honest science lies. Start with the on switch. Classic psychedelics like psilocybin and LSD work mainly through one target, the serotonin 2A receptor. We know this because of an elegant experiment. Give someone a blocker called ketanserin first, and the psychedelic experience almost completely fails to launch. Plug that one keyhole and the cosmos-sized feeling never arrives. And if you give the blocker after the trip has already begun, it doesn't erase it. Cuts it short. In one study, the effects of LSD shrank from about 8.5 hours down to 3.5. The experience that feels like touching the infinite turns out to run through a receptor smaller than a wavelength of light. The infinite has an off switch. Sit with that for a second. Now, what happens inside? The leading character in this story is the default mode network. It runs when your mind wanders, when you replay memories, when you think about yourself. Under psilocybin, brain imaging consistently shows this network's internal activity and connectivity drop. Its tight, self-referential chatter loosens. The first landmark study saw this in just 15 volunteers, and it has been seen again since. And here is the part that gives people chills. In these early, small studies, the more a person's sense of self dissolves, the more their brain's normal boundaries appear to blur on the scan. The walls between separate networks soften. The felt experience of losing yourself seems to have a measurable fingerprint in the wiring. The subjective and the physical line up. But be careful here because honesty matters. Early work described this as global connectivity rising, everything talking to everything. Newer, sharper studies describe the dominant effect almost the opposite way. The brain desynchronizing, falling out of step with itself. The samples are small. The exact direction is still being argued. What everyone agrees on is that the normal order breaks down. That breakdown is the heart of a big idea called the entropic brain hypothesis. Normal waking consciousness, it proposes, sits in a tight, orderly, low-entropy state. Psychedelics push the brain toward higher entropy. More disorder. More flexibility. Less rigid self-modeling. Think of a snow globe being shaken, and the settled pattern temporarily set free. But mark this clearly. The entropic brain is a leading framework, not proven law. The claim that richer consciousness simply scales with more entropy has real counterexamples, and serious researchers still debate it. We are watching a theory being built, not reading one from a textbook. There's a refinement of the idea called REBUS, relaxed beliefs under psychedelics. The brain is a prediction machine, constantly betting on what reality is. REBUS says psychedelics turn down the confidence in your highest level beliefs, including your belief about who you are. For a few hours, a story your brain holds as unquestionable becomes editable. Rivals argue it credits the brain. Alone too much. The debate is open. Now the second mystery. Why can one dose matter for months? Here the answer points to growth. In animal and cell studies, psychedelics act as psychoplastogens. They rapidly sprout new dendritic spines, the tiny connection points between neurons. A 2023 study found the trigger sits at receptors inside the cell, which is why ordinary serotonin can't do it, but these molecules can. Crucial caveat. This is mostly mice and cells. Human proof is still being built. One dose. Months of change. Nobody fully knows why. And this splits the field in two. One camp, built on Johns Hopkins data, says the overwhelming experience itself is the medicine. The intensity of it predicts who gets better. The other camp is literally engineering psychedelics with the trip removed, betting the synapse growth does the healing without the vision. Nobody has settled it. Imagine that. We may not yet know whether the meaning or the molecule does the work. So what about depression? The trials are real and genuinely promising. In the largest controlled study, a single dose with psychological support produced a significant drop in treatment-resistant depression at 3 weeks. But the effect faded for many by 12 weeks, and the high-dose group carried a serious safety signal. In a head-to-head against a standard antidepressant, psilocybin did not clearly win. This is early-stage research, not a prescription. Educational only, not medical advice. Promising is not the same word as proven. Hold both at once. So let's sort it honestly the inner cosmos way. Proven, the experience runs through the serotonin 2A receptor, and in animals these molecules grow new synapses. Emerging, the entropic brain, REBUS, and the depression trials are real, promising, and unfinished. Belief, that ego dissolution reveals a cosmic consciousness or a soul. Science can measure that it feels profoundly real and meaningful. Cannot confirm the metaphysics. We hold that with respect and we label it as belief. And the myths. No, psychedelics do not unlock the unused 90% of your brain. You already use virtually all of it. These molecules change how it talks to itself, not how much switches on. No, one trip is not permanent enlightenment. Benefits can fade and context matters. And no, they are not safe for everyone. The real risks are real. Lasting visual disturbances and triggering psychosis or mania in vulnerable people, which is exactly why researchers screen so carefully. One more honest note. People assume this is sliding smoothly toward your pharmacy. It isn't yet. The first MDMA-assisted therapy application, and MDMA is a cousin of these drugs, not a classic psychedelic, was turned down by the FDA in 2024, which asked for another trial over how the studies were run. The science is thrilling and unfinished, and saying so out loud is the entire point of this channel. So come back to where we started. The feeling of being a separate self is something your brain produces. We can find the receptor. We can watch the network come apart. We can see the synapses grow. And yet we still can't agree on which of those is doing the real work. So here's the question I want to leave with you. If the feeling of being you can be loosened, even briefly switched down, then who or what is left in the room when it does? Tell me in the comments. If you're fascinated by where science meets wonder, subscribe and stay curious. Because here's what we chase next in video 5. Is reality real? If the self can be an illusion the brain builds, what about everything else? Next time we ask whether reality itself is real, and what the science actually says about simulation theory.